Did you know that over 50 billion eggs are used each year solely to produce mayonnaise? This creamy, ivory white sauce isn't just the soul of modern fast food, it's also an addiction for millions of food lovers. But have you ever wondered what's really inside those jars of sauce? What gives it that irresistible appeal? The secret begins at the egg farms, where tens of thousands of fresh eggs are collected daily and transported to the factory. There, through a combination of cutting-edge machinery and a secret blending formula, these ordinary eggs are magically transformed into a rich, velvety, and incredibly flavorful sauce. Today, Agriculture Insight takes you behind the scenes to explore the full journey of how this iconic condiment is made and why mayonnaise has become an irreplaceable symbol in global cuisine. You might think of mayonnaise as just a simple condiment in your daily sandwich or salad. But in the global food industry, this creamy sauce is considered white gold, generating a staggering $14 billion in revenue each year. In the global condiment market, the US holds the crown thanks to its massive production scale and advanced technology. Led by Hellmann's, the giant brand that commands 45% of the North American market. Every day, around 1.2 million bottles of mayonnaise are produced and shipped from Hellmann's factories, finding their way onto millions of dining tables worldwide. If Hellmann's is the king of the mainstream, familiar, easygoing, and everywhere, then Duke's is the choice for the few. With a no-sugar formula, a thick and creamy texture, and a bold southern flavor, Duke's doesn't aim to please everyone. It wins over those who value authenticity and demand precise control over every ingredient. To produce millions of jars of high-quality mayonnaise each day, it all starts with one essential ingredient: eggs. And that journey begins on the laying hen farms. There's a little-known fact. Egg quality doesn't depend solely on breed or nutrition. It also stems from the hen's comfort, living conditions, and stress levels. In modern farms, animal welfare is no longer a choice, it's a technical standard. Laying hens are raised in clean, well-ventilated housing systems, with natural lighting and fresh air circulation controlled automatically around the clock. Their diets are carefully tailored to each growth stage, rich in protein and balanced in minerals, to strengthen immunity and ensure consistent laying cycles. There's no panic clucking, no overcrowding, no unpleasant odors. Instead, a closed-loop system is maintained, where every egg is produced under optimized conditions of nutrition, environment, and health. It's the foundation behind the consistent quality of millions of jars of mayonnaise. After a period of meticulous care, the hens enter their laying phase. In modern farms, whether free-range or industrial, the health and productivity of each hen is closely monitored to ensure optimal efficiency. Nesting areas are specially designed with clean, cushioned spaces, providing a calm environment for the hens to leave behind a fresh gift each day. On average, a hen lays one egg every 26 hours, nearly one egg per day. At an industrial scale, egg collection is handled by highly efficient automated systems. As soon as the egg drops onto a soft tray beneath the nest, it is gently transferred onto a conveyor belt that runs the length of the housing rows and carries it straight to the central collection area, without any human intervention. Thanks to this system, large farms can gather between 200,000 and 500,000 eggs per day, meeting the enormous raw material demand of the mayonnaise industry. If that number feels hard to grasp, consider this. Eating through all those eggs would take over 1,300 years, assuming you had the lifespan of a legendary tortoise. Once collected, the eggs are temporarily stored under tightly controlled temperature and humidity conditions before continuing on to the next stage, processing at the factory. Mayonnaise is primarily made from egg yolks and vegetable oil. Therefore, handling the eggs properly, before they enter the production line is a critical step. As soon as the eggs arrive at the facility, they undergo a strict quality control process. Advanced LED candling systems and high-resolution image sensors are used to detect any defects such as hairline cracks, thin shells, fertilized eggs, or internal impurities. At the plant, more than 60,000 eggs can be inspected every hour, fully automated, with no manual handling required. Any egg that fails to meet the standards is immediately removed from the production line. Only those that pass strict criteria for shape, size, and safety are allowed to proceed. In certain markets like the United States, egg washing is a mandatory step to remove dirt, feathers, and surface bacteria. Eggs are sprayed with warm water, combined with a mild sanitizing solution to clean the shell without compromising the structural integrity of the egg inside. However, in Europe, this process is generally avoided to preserve the egg's natural protective layer, the cuticle, which helps prevent bacterial intrusion. Instead, strict hygiene standards are enforced throughout the production and storage process to maintain cleanliness without stripping away this natural barrier. After washing, the eggs are sorted using an automated weighing system. Each egg is weighed and categorized into standard size classes, such as S, M, L, or XL. This classification ensures consistency in egg size across production batches, helping maintain stable, predictable quality in the mayonnaise manufacturing process. Next, the eggs are transferred to a specialized separator to extract the yolks, the key ingredient in mayonnaise, as they contain lecithin, a natural emulsifier that allows oil and water to blend smoothly. The machine operates based on physical separation principles such as centrifugal force, gravity, or rolling mechanisms, starting with a gentle cracking of the shell to avoid breaking the yolk. Compared to manual labor, modern separation machines are 10 to 20 times more efficient, capable of processing thousands of eggs per hour. These systems not only save time but also ensure that the extracted yolks are pure, hygienic, and ideal for high-quality mayonnaise production. The yolk is then separated from the white and shell through dedicated chambers. The system operates at speeds of up to 60,000 eggs per hour, yet the yolk breakage rate remains below 2%. After separation, the liquid yolk is passed through a low-pressure microfiltration system to remove any remaining impurities or shell fragments. It then undergoes low-temperature pasteurization, around 60 to 65 degrees Celsius, a process gentle enough to eliminate harmful bacteria without denaturing lecithin. After processing and preparation, the products are packed into specialized containers, stored under strict conditions, and transported to mayonnaise manufacturing facilities to be used as a key ingredient in the next stage of production. In addition to using liquid yolk, many factories also convert yolk into dried egg powder through spray drying or freeze drying methods. When rehydrated with water, this powder restores the emulsifying properties of fresh yolk, preserving the flavor and thickness of the mayonnaise. And now, let's dive into the mayonnaise production process, the part we've all been waiting for. This is where science, precision, and flavor come together to create one of the world's most iconic sauces. First, the pasteurized liquid egg yolk is automatically pumped from intermediate storage tanks into large stainless steel mixing vessels, each with a capacity ranging from several hundred to several thousand liters. This closed-loop pumping system prevents external contamination and preserves the yolk's integrity, ensuring maximum purity and optimal emulsifying properties. In some factories, fresh yolk is replaced with dried egg powder, a remarkable ingredient that can be revived with just pure water. Before use, the powder is finely sifted under high pressure to remove clumps and impurities, then dissolved at precise ratios in a specialized mixing tank. After the egg yolk is pumped into the mixing tank, other ingredients such as vinegar or lemon juice, salt, sugar, and various additives like mustard, stabilizers, and flavor enhancers are added in a programmed sequence. Have you ever wondered why a bit of mustard appears in mayonnaise recipes? It's not there to add the spicy kick you'd expect in a hot dog. Instead, it rounds out the flavor, adds depth, and more importantly, it helps emulsify. The amount is so small you might not notice it's there, but take it away, and you'll feel like something's missing, even if you can't quite explain what. Finally comes the refined vegetable oil, most commonly soybean oil, which accounts for 65 to 80% of the total mixture and plays a key role in giving mayonnaise its rich texture and creamy body. Soybean oil is chosen for its neutral flavor, excellent emulsifying ability, and high stability. Before being used in production, the oil undergoes a thorough refining process, including deodorization, decolorization, and impurity removal to ensure absolute purity. This level of refinement helps create mayonnaise with a smooth, creamy texture, an appealing ivory white color, and an extended shelf life. Once all the ingredients have been added in the correct order and roughly blended, the mixture enters the emulsification stage, the most critical step in the entire production line. Here, high-speed mixing equipment, operating at up to 3,000 revolutions per minute, works continuously to disperse oil droplets evenly into the water phase. Egg yolk, naturally rich in lecithin, acts as a powerful emulsifier, stabilizing the structure of the mixture and preventing separation over time. In most modern systems, emulsification and homogenization happen at the same time, all inside one machine. As the high-speed mixer runs, it breaks down the oil into tiny droplets, that's homogenization, while the lecithin in the egg yolk wraps around those droplets and helps bind them with water. That's the emulsifying part. This combo gives the mayo its smooth, creamy texture and keeps it from separating over time. Once the process is done, the mixture gets pretty warm from all that mixing, so it's quickly cooled down to lock in the structure and preserve the fresh taste. Before entering the packaging stage, technicians collect samples of the mayonnaise for testing. The product must pass strict evaluations for viscosity, pH, color, taste, and emulsion stability to ensure consistent quality and food safety. At the same time, microbiological tests are also carried out to detect and eliminate any risk of contamination. After passing rigorous quality checks, the finished mayonnaise is pumped into various types of packaging, including plastic bottles, single-serve sachets, and glass jars, all carried out on a fully automated, closed-loop packaging line. For jars and bottles, automated filling systems dispense the mayonnaise with milliliter-level precision. In advanced facilities, the line can fill up to 15,000 bottles per hour, meeting the demands of high-volume global production. Once filled, each unit moves to the capping station, where lids are sealed tightly with even mechanical force to ensure an airtight seal. Labels are then automatically applied, displaying full traceability and expiration details. From filling to final packaging, every step takes place in a strictly controlled environment to ensure hygiene and precision, minimizing contamination risks and preserving product integrity until it reaches the consumer. For single-use sachets, the mayonnaise is dispensed and heat-sealed in a matter of milliseconds using high-speed sealing technology. The entire process from filling to sealing takes less than 1 second per unit. And from the very first egg to the final squeeze of sauce, every jar of mayonnaise is the result of cutting-edge technology, engineering precision, and meticulous care at every stage of production. However, that guilty feeling after the first spoonful is hard to avoid. Behind its smooth, rich, and creamy texture lies an energy bomb, with nearly 100 calories per tablespoon, making mayonnaise one of those deceptively indulgent foods that can quickly lead to weight gain if you're not careful. If there were a global strawberry showdown, China would be crushing it in volume, but the United States, it's leading in prestige. In China, over 3 million tons of strawberries are harvested every year, nearly 3 times more than the US. An impressive number, no doubt. But if you ask the world which strawberry jam brands they actually remember, the answer lies across the Pacific. Smucker's, Bon Maman, Welch's, and a lineup of legendary names all hail from America. Because in the US, strawberry jam isn't just a breakfast spread. It's a culture, an industry, and the global gold standard of sweet perfection. The US may not grow the most, but it knows how to turn a humble berry into something the world loves to spread on toast every morning. The reality is, not every strawberry makes it to consumers while still fresh. Left too long, it spoils quickly, and that's exactly why the processing industry exists. Turning strawberries into jam isn't just about preservation, it's a way to extend the life of a delicate fruit, reduce waste, optimize the supply chain, and transform something fragile into lasting value. At high-end strawberry farms, where every berry is selected for export or premium jam production, automated harvesting machines are becoming the go-to solution. Equipped with AI-powered cameras and soft robotic arms, these machines can accurately identify ripe strawberries and gently pluck them using silicone grippers or vacuum suction without damaging the fruit or tearing the stem. The entire process is smooth and precise. Each berry is placed into soft, cushioned trays immediately after picking to preserve its shape and freshness. A single machine can harvest up to 10,000 pounds of strawberries per day, operating mainly in the early morning hours, the golden window to lock in flavor and quality. Even as technology reaches into every furrow of the field, in the United States, strawberry harvesting, especially on organic farms, hilly terrain, or hard-to-reach areas, still belongs to the hands of human workers. Strawberry pickers move like silent artisans, carefully weaving through the rows, selecting the perfect berries at just the right moment. Each fruit is gently placed into ventilated plastic trays, lying in a single layer like eggs in a nest. No stacking, no crushing, no bruising. Once a tray is full, they make their way quickly back to the collection point to transfer the berries into cold storage. This must happen within 1 to 2 hours of picking. Any delay and the quality starts to slip away. On average, each picker harvests between 9 to 13 kilograms of strawberries per hour. It may not sound like much, but this work supports over 55,000 seasonal jobs across the U.S. each year, most of them held by immigrant agricultural workers. Hand-picking doesn't just preserve the quality of each berry, it sustains the livelihoods of tens of thousands of families. That's why the American strawberry industry is not only efficient, but deeply human at its core. After harvesting, strawberries are quickly transported to nearby pre-processing facilities, usually located close to the farms, where sorting begins while the fruit is still at peak freshness. This step plays a critical role in determining the destiny of each berry. Some will be selected for fresh sale at supermarkets or local markets, while the rest will enter processing lines to become jam, frozen fruit, or dried products. Only the highest quality berries, bright red, plump, unbruised, and free of pest damage, are kept, while those that are soft, scratched, or uneven in color are removed immediately. Sorting requires not only a keen eye, but also speed and experience, as strawberries begin to lose freshness rapidly, just a few hours after being picked. On large farms, harvesting may take several days, and sorting can continue non-stop from morning until night. Careful sorting ensures not only product quality, but also efficiency in the next stages of production. Each selected strawberry must be evenly ripe to guarantee consistent color, texture, and overall product quality. After careful sorting, the selected strawberries are gently packed into specialized boxes or cartons with soft padding and ventilation holes to protect the fruit throughout transport. These boxes are then sent directly to cold storage facilities, where stable, low temperatures help preserve their freshness and quality. From there, part of the strawberries is distributed to local supermarkets to meet domestic demand, while higher-grade batches continue their journey toward export markets, appearing on breakfast tables across the United States, Europe, and Asia. But what about the strawberries that don't make it to the fresh market? They're given a second, sweeter destiny, heading straight to jam factories. As soon as they enter the line, strawberries are preliminarily sorted and neatly placed into individual molds, ready for stem removal. More than 2,000 berries per minute glide through an automated blade system, where each stem is sliced cleanly with near-perfect precision. A deviation of just a few millimeters can cause the blade to cut into the soft flesh, distorting the berry's shape, and in this industry, even the slightest imperfection can instantly cut its commercial value in half. Strawberries are then placed on rotating rollers and pass beneath a series of high-pressure water jets. These jets are carefully calibrated to remove dust and surface residue without bruising the delicate fruit. Immediately afterward, the berries slide into a high-capacity washing tank, where powerful water agitation dislodges any remaining sand, stems, or leaf fragments. Throughout this process, a network of guide rails ensures the berries remain evenly spaced and cushioned, reducing physical impact and preserving the fruit's integrity during continuous cleaning. This multi-stage wash is critical for meeting food safety standards while maintaining the berry's appearance and texture. After cleaning, the strawberries move on to an inspection belt, where trained workers manually sort through each batch. Damaged, overripe, or discolored berries are quickly removed to ensure only high-quality fruit continues down the line. This hands-on step adds an extra layer of quality control that machines alone can't guarantee. Now, let's take a closer look at a process we rarely get to see, but one that plays a crucial role in preserving the full flavor and value of every single strawberry: freeze-drying. The process begins with an ultra-fast deep freeze, plunging the strawberries to around -40 degrees Celsius. The frozen strawberries enter a vacuum drying chamber. Through a process called sublimation, the ice within the fruit evaporates directly into vapor. A powerful upward airflow lifts the berry pieces slightly, causing them to bounce and hover just enough to stay separated. What makes freeze-drying stand out isn't just the technology, but the results. Unlike conventional drying methods, which can strip away up to 40 to 50% of the fruit's vitamin C, freeze-drying retains more than 95%. The strawberries emerge light, crisp, and intensely flavorful, packed with their original sweetness, natural aroma, and essential nutrients almost completely intact. After passing through the freezing tunnel, the strawberries move on to manual inspection, where workers carefully sort through each frozen piece, removing any that are bruised, freezer-burned, or don't meet quality standards. Once the freezing process is complete, the strawberries are transferred to the packing area. Each batch is carefully weighed and poured into food-grade bulk bags. Workers quickly fold and seal the tops using a heat-sealing machine, ensuring an airtight closure to prevent moisture buildup. These frozen strawberry bags are then transferred directly to deep freeze storage, where they are kept at ultra-low temperatures to maintain peak quality, patiently awaiting shipment to jam factories for the next stage of production. At last, we've arrived at the most anticipated stage inside the jam factory, where frozen strawberries begin their transformation into irresistible jars of sweet, velvety jam. The frozen strawberries are carefully thawed under strictly controlled conditions. This process typically takes 4 to 6 hours at a chilled temperature of around 0 to 4 degrees Celsius to prevent thermal shock, which can cause excess moisture release, softening, or discoloration. The strawberries are then transferred into large-capacity industrial cooking kettles, specially designed to distribute heat evenly and maintain stable temperatures throughout the cooking process. Here, the strawberries are combined with sugar, pectin, a natural gelling agent derived from plants, and sometimes lemon juice or citric acid to balance the sweet tart flavor and achieve the ideal thick, jam-like consistency. Throughout the cooking process, the mixture is continuously stirred by automatic paddles to prevent scorching at the bottom and to help maintain the strawberries' vibrant red color. Cooking typically lasts between 30 and 45 minutes, with constant checks on viscosity, aroma, and brix levels to ensure consistent quality in every batch. If you look closely during the cooking process, you might notice a small amount of white powder being added to the mixture. This is usually pectin or citric acid in crystalline form, added at different stages to adjust the jam's gelling properties. And here's where the biggest secret in the strawberry's sweet journey is revealed. Under the intense heat of cooking, the berry's vibrant red color begins to fade, replaced by a deeper brown hue, a result of a chemical reaction between sugar and anthocyanin, the fruit's natural pigment. This leads to a surprising truth. The bright red color you see on your favorite jar of strawberry jam isn't actually the berry's real color after cooking. To preserve the iconic look of this beloved treat, many manufacturers quietly add natural coloring derived from red beet or blackcurrant. A sweet little twist in the world of food, where eye-catching appearances sometimes come from something entirely unrelated to strawberries. Once the jam reaches the perfect consistency and flavor, it is still piping hot when poured directly into sterilized glass jars or specialized plastic containers. The filling process is fast but precise, ensuring the jam maintains a high enough temperature to naturally sterilize each jar. Each stream of jam flows like a ribbon of golden sweetness, but behind that smooth texture lies a highly precise technical requirement. The filling process is extremely fast, yet must be carried out with absolute accuracy, because the jam must be poured while still hot, typically at 85 to 90 degrees Celsius, to achieve natural sterilization inside the jar. This temperature not only eliminates potential bacteria, but also creates a mild vacuum as it cools, keeping the jam safe without the need for added preservatives. Right after being sealed, the jam jars pass through a cold water spray system. This cooling step quickly brings down the internal temperature, preventing the jam from continuing to simmer inside the jar and helping to preserve its ideal texture, color, and flavor. Next comes the final finishing stage. Each jar of jam, after a final quality check, is labeled clearly and printed with complete information about ingredients and expiration date, ensuring transparency and convenience for consumers. The jars are then neatly packed into sturdy, well-lined cartons to prevent damage during transport. These finished cartons are transferred to deep cold storage, where stable, year-round temperatures provide ideal conditions for preservation. Here, the jam jars go into a brief hibernation period, allowing shelf life to extend while maintaining their texture, consistency, and flavor, until they're ready to head out to supermarkets or find a place in your kitchen. And that's the meticulous journey behind every jar of vibrant strawberry jam, sweet from the fields to every spoonful you enjoy. Each jar is the result of a careful process of selection, processing, and dedication. Don't forget, there are still many exciting journeys ahead, uncovering the fascinating stories behind everyday foods. If you found this video enjoyable and informative, please like, share, and leave a comment to support us. California, particularly the San Joaquin Valley, is proudly known as the raisin capital of the U.S., producing 100% of the nation's raisins. Here, over 1,500 dedicated farmers tend to sprawling vineyards that stretch across more than 100,000 acres, thriving in the region's warm climate and fertile soil, perfect conditions for growing grapes. American raisins are primarily made from green grapes, especially the Thompson seedless variety. This seedless grape boasts a naturally sweet flavor, thin skin, and an ideal texture for drying, allowing it to retain its signature chewy softness and rich taste. It's no wonder this grape is the heart and soul of America's raisin industry. The journey to create these sweet little delights begins with tiny grapevine sprouts, where life first takes root. The process of creating grapevine seedlings starts with mother vines in the vineyard. These mother vines are meticulously cared for and thoroughly inspected to ensure they are free of pests and diseases. Cuttings are typically harvested during the winter months, when the vines are dormant, to minimize potential damage during handling. Once harvested, the cuttings are bundled and loaded onto trucks for transport to the production facility. At the production facility, the grape cuttings are straightened using specialized machinery to remove any bent or substandard sections. They are then trimmed into smaller segments that meet the standard size for grafting. This process ensures uniformity and quality, preparing the cuttings for the next steps in the propagation process. The rootstocks are carefully gathered into large bundles to ensure they are easy to handle during the next steps. Once bundled, they are immersed in a specially formulated chemical solution designed to stimulate sprouting and encourage healthy growth, giving the grafted vines the best possible start. In a similar manner, the budwood is meticulously trimmed into smaller, uniform pieces, much like the preparation process for the rootstock. The trimmed grape cuttings are grafted onto rootstocks using the precise omega grafting technique. This method ensures secure unions and a seamless connection between the scion and rootstock. Precision is key in this process, as it significantly affects the survival rate of the grafted cuttings. Once grafted, each union is carefully inspected to ensure it is neither loose nor misaligned. After budding, the grapevine branches are usually dipped in a special solution to improve the success rate. This solution often contains fungicides to prevent diseases and growth hormones to speed up healing at the grafting site. The grafted cuttings are then placed in trays filled with a sawdust-like medium, often coir, a renewable coconut fiber. This environment retains moisture effectively, providing ideal conditions for the grafts to heal and sprout. The rooting process lasts about 18 days and is closely monitored to maintain optimal temperature and humidity levels. Once the plants in the greenhouse reach the desired size and health standards, they are harvested and dipped in paraffin wax. This wax coating helps protect the plants from moisture loss and environmental stress during their transition to outdoor planting. This step is crucial to ensure the seedlings retain their vitality and remain robust during transport and planting. Next, grape planting machines are brought into action. These machines are equipped with seats for workers, who carefully place each seedling into the rotating mechanism of the machine. As the machine moves slowly across the field, it plants each seedling at the correct depth and spacing. Simultaneously, the machine gently compresses the soil around the seedlings to secure them and promote healthy root development. This process reduces manual labor and maximizes planting efficiency. Throughout the growing season, the grape plants are irrigated using a drip irrigation system. Fertilizers and growth stimulants are applied according to a schedule to ensure the plants grow strong and healthy. Regular pest and disease control measures are also implemented to protect the plants from potential threats. At the end of the growing season, as the plants enter dormancy, they are harvested using specialized machinery. These machines gently dig up the seedlings and group them into bundles, ensuring that the roots and stems are not damaged during the process. The bundled seedlings are then transported to the processing facility for further treatment. At the facility, the seedlings undergo a final inspection. The roots and stems are trimmed to remove any unnecessary parts. The seedlings are then dipped in a green protective solution designed to shield the roots from bacteria and fungi while retaining moisture. This treatment helps prepare the seedlings for transportation and ensures their health and vitality are maintained during the next stages. These bundles are stored in cold storage facilities to maintain their freshness and vitality until they are ready to be shipped to commercial vineyards. The seedlings are then transported to commercial grape-growing farms. Before planting the vines, farmers prepare the fields by installing sturdy wooden or metal posts along the vineyard rows using specialized machinery. These posts serve as the framework for trellises, supporting the grapevines and guiding their growth for optimal sunlight exposure and air circulation. Next, grape planting machines are brought into action. These machines are equipped with seats for workers, who carefully place each seedling into the rotating mechanism of the machine. As the machine moves slowly across the field, it plants each seedling at the correct depth and spacing. Simultaneously, the machine gently compresses the soil around the seedlings to secure them and promote healthy root development. This process reduces manual labor and maximizes planting efficiency. Once planted, the grapevines are nurtured with the help of modern equipment to ensure healthy growth and high productivity. Pruning machines are used to quickly remove unnecessary branches, improving airflow and allowing the vines to concentrate their energy on fruit production. To protect the vines from pests and diseases, advanced sprayers apply protective treatments evenly across the vineyard canopy, ensuring the plants remain in peak condition. Modern machinery makes clearing weeds around grapevines a fast and efficient process. Equipped with precision blades and sensors, these machines can cut weeds close to the base of the vines without damaging the plants. Grapevines typically start producing fruit about 2 to 3 years after planting. In California, grapevines bloom between May and June, during spring and early summer. It takes around 3 months for the grapes to reach their peak ripeness. Once they are fully ripe, farmers often use the traditional method of allowing the grapes to dry naturally on the vine. This process, taking about 2 to 3 weeks, causes the grape skins to transform from green to a light golden brown hue, indicating the natural drying process is underway. Specialized harvesting machines are used to collect them. These machines gently shake the vines, causing the dried grapes to fall onto soft collection trays below, minimizing damage. The raisins are laid out in carefully prepared rows on the ground to dry completely under the sun. Once the raisins have reached their perfect level of dryness, another machine gently lifts them from the ground into containers, preparing them for transport to the processing plant. This method saves time and protects the quality of the raisins. In some areas, instead of letting grapes dry naturally on the vine, farmers harvest the ripe grapes and bring them to designated drying areas. Here, they are dipped in a chemical that dries the grapes quickly in just a few days. The grape clusters are evenly spread out on sheets of paper or fabric laid on the ground, where they are exposed to natural sunlight. This sun-drying process lasts several days to a few weeks, depending on weather conditions. The grapes gradually lose moisture and develop their characteristic sweetness and chewiness. Once the grapes have dried to perfection, they are collected and transported to processing facilities for cleaning, sorting, and packaging. At the factory, the raisins first pass through a vibrating system that helps loosen and remove debris like stems, leaves, or dirt clinging to the surface. From there, they move to a water-based cleaning system, where they are thoroughly washed to ensure they meet strict hygiene and quality standards before further processing. Next, the raisins are passed through a drying system to remove all moisture. Next, they are sorted automatically by size, color, and quality. Raisins that don't meet quality standards are removed or used for other purposes, such as livestock feed. After that, they move to the manual sorting stage. Workers stand along both sides of a moving conveyor belt, carefully inspecting the raisins as they pass by. Finally, the raisins are packed into vacuum-sealed bags or airtight containers to retain their freshness and natural flavor. The packaging is labeled with information about the origin, nutritional facts, and expiration date. The finished product is then distributed to stores and consumers worldwide. California raisins are a pantry favorite in many homes across the U.S., known for their natural sweetness and chewy texture. Grown mainly in the sunny Central Valley, these little gems start as Thompson seedless grapes, dried right in the vineyards under the California sun. They're perfect for adding a burst of flavor to your oatmeal, cookies, or even a quick trail mix snack. Beyond the kitchen, raisins are also a go-to healthy treat for kids and adults alike, packed with energy and nutrients. From school lunches to family recipes, California raisins have a way of making everyday meals just a little bit better. We've just explored the incredible journey of grapes. Feel free to leave a comment if you have any questions or thoughts. Don't forget to like and subscribe to my channel. Typically, oat plants require about 90 to 120 days after planting to reach the harvest stage. When the lush green fields of oats transform into a stunning golden hue, it signals that the grains on the stalks have ripened perfectly and are ready for harvest. This process not only demands precision, but also requires a seamless blend of advanced technology and the expertise of American farmers. When the time comes, the powerful combine harvesters are put into action. These machines are specially designed to perform multiple tasks simultaneously: cutting, threshing, and handling the stalks. At the front, a row of sharp blades cleanly cuts through the oat plants as the machine moves forward. Inside, the system efficiently separates the oat grains from the stalks using sieves and blowers. The harvested grains are then collected in an integrated storage bin, ready for transport. Meanwhile, the stalks are shredded and evenly spread back onto the fields, serving as a natural fertilizer to enrich the soil and maintain its fertility for future crops. One of the highlights of this process is its precision and efficiency, made possible by advanced technology. Modern combine harvesters not only work quickly, but also minimize grain loss during harvesting. With the support of GPS systems and smart sensors, farmers can monitor harvest progress and yield in real time. This data is invaluable, not only for optimizing the current harvest, but also for improving farming practices in the future. Once the storage bins on the combine harvesters are full, the harvested oats are transferred to specialized trucks. Many large farms in the U.S. use automated transfer systems, allowing oats to be seamlessly moved from the harvester to the truck without stopping. This saves time and ensures a continuous workflow, which is especially crucial on vast fields spanning thousands of acres, where every second matters to avoid adverse weather conditions that could jeopardize the crop. Compared to traditional manual harvesting methods, modern machinery not only reduces labor costs, but also significantly boosts productivity and enhances the competitiveness of American agricultural products in global markets. Beyond improving efficiency, these machines play a crucial role in environmental protection. Advanced harvesters are designed to save fuel and minimize carbon emissions while making full use of the oat plants. The shredded stalks are not wasted, but are repurposed directly on the fields as natural fertilizer, replacing the traditional practice of burning straw, which contributes to air pollution. Trucks loaded with freshly harvested oats from vast fields roll into the processing plant, carrying the golden grains of the season. Here, the oats are unloaded onto a conveyor belt that leads directly to a vibrating cleaning machine. This machine acts like a meticulous inspector, removing dirt, stones, and other impurities left from the harvesting process. Once cleaned, the oats continue their journey along the conveyor belt, heading toward the dehulling machine. The dehulling machine plays a crucial role in removing the tough outer shell that encases each oat grain. These husks are not wasted but are collected and repurposed as cattle feed, ensuring an efficient and sustainable use of resources. Meanwhile, the dehulled oats, the most valuable part, continue their journey along the conveyor belt to the steam kiln. Here, the oats are treated with high heat and steam, a process that not only enhances their flavor but also ensures consistent quality and extended shelf life. After leaving the steam kiln, the oats are sorted by size and color using advanced automated scanning systems. Larger uniform grains are directed to machines for rolling and cutting. This process creates instant oats, a popular choice for quick and convenient breakfasts. Once rolled thin, the oats are packaged on site at the factory, ready to be stocked on store shelves and delivered to consumers. Meanwhile, smaller oat grains that don't meet the standards for instant oats are sent to the grinding machines. These machines process the grains into fine oat flour, a versatile ingredient perfect for baking and nutritious meals. Once ground, the oat flour is carefully packaged into bags or larger sacks, ensuring easy transport and long-term storage. Oats can also be used to create other ready-to-eat products, like cakes and milk. High-quality oats, once rolled, are mixed with ingredients such as sugar, butter, and flavorings in large industrial mixers. The mixture is then shaped into cakes and baked to a golden perfection in modern ovens. Once cooled, the cakes are automatically packaged in airtight wrappers to retain their crispness and fresh flavor before being distributed to stores and supermarkets. To produce oat milk, oat grains are soaked in water and blended into a fine consistency using high-speed grinders to extract the milk. The mixture is then filtered to remove the pulp, leaving behind smooth, creamy oat milk. Next, nutrients such as calcium and vitamins are added, and the milk is pasteurized to ensure food safety. Finally, the oat milk is automatically bottled and sealed, ready to be transported to consumers. The oat processing procedure at the factory not only ensures top-quality products, but also maximizes the use of every part of the oat plant, from the grain to the husk. Every step is carried out with precision and efficiency, delivering nutritious and convenient products that serve millions of meals around the world. Across vast fields, oat seeds are sown with precision using modern seeders, ensuring uniform spacing and optimal depth for healthy growth. Before planting, the soil is thoroughly tilled by powerful tractors, creating a loose, well-aerated base that allows the oat seeds to take root and thrive effectively. After planting, automated irrigation systems combined with moisture sensors ensure optimal conditions for germination and growth. The fields soon transform into lush green carpets, promising a bountiful harvest ahead. Oats have long been an essential part of American life, valued not only for their nutritional benefits, but also for their convenience. As a top choice for breakfast, oats reflect a commitment to healthy living and mindful eating. Products like instant oats, oat flour, and oat milk are not just staples on the dining table, but have also become key ingredients in many modern recipes and beverages. From families to fitness communities, oats serve as a source of inspiration and a symbol of simplicity, packed with nutrition, enriching the culinary culture of America. We've just explored the incredible journey of oats, from golden, sprawling fields to precise harvesting processes and their transformation into nutritious products like instant oats and delicious oat flour. Thank you for joining me on this journey. If you have any questions or feedback, feel free to leave a comment below. Don't forget to like and subscribe to the channel for more fascinating stories about the world of agriculture. See you in the next video.